Welcome everybody, Adele from Food Focus. This is our 9th webinar this year with the DSA, and we are very grateful for our working partnership with one of our long-standing sponsors, the DSA. One of the DSA's main activities is liaising with and communicating with all relevant stakeholders to assist in improving and maintaining the quality of dairy products. The webinars are focused on different topics to keep you informed, and the previous webinars are all posted on the Dairy Standard website. Today, we are speaking about a practical approach to hygienic design of dairy equipment. The hygienic design of dairy equipment aims to prevent contamination, biological, chemical, as well as physical, of the product or the material. A prerequisite program supports HACCP in a food safety management system by limiting the number of foreseeable hygienic risks to a practical minimum and by facilitating mitigation measures such as cleaning and disinfection. In this webinar, Piet will focus on the hygienic design principles and hygienic design risk management protocols. And with that, it gives me pleasure to introduce you to Piet. Piet has gained expert knowledge in various aspects of hygiene, food safety, and hygienic design within the food and beverage industry across various sectors. During the past 38 years, he's been in industries like alcoholic, non-alcoholic beverages, dairy, fish, poultry, processed food, as well as agriculture. Actively participating in working groups, reviewing and rewriting national standards, qualifying himself in the design and audit of GMP's food safety management systems, and also championed due diligence projects, including the implementation of food safety management systems for local and international customers. Piet is privileged to present on the topic of hygiene, food safety and hygiene design at various events arranged by industry associations, universities and customers. As a subject matter expert, Piet presented at international conferences, including the Institute of Brewing and Distilling, Africa, at Sun City, South Africa, and the All Indian Brewing event in India. Piet, that is a very impressive CV, and it gives me great pleasure to hand over to you so that you can present to us your presentation. Thank you, Piet.
Right. Thank you so much for the introduction. It's much appreciated. Just on first things first, I would like to thank the Dairy Standards Agency, DSA, and YOMPI specifically for this opportunity to conduct this webinar. I actually hold a couple of hats. Just explaining that I'm on EH, it's the acronym for European Hygienic Engineering Design Group. I chair the regional section for Southern Africa. I am the head of food safety and hygiene for the OFT group. And then I'm the sales director for Centrotech, providing hygiene solutions to the food and beverage industry. So that just as per the introduction. In terms of our agenda, just the introduction to EH. We'll talk about hygienic design principles, very important when we speak later about hygienic design risk management. We'll see how it links. I would like to share with you some practical approaches that we've done, some case studies where I've been personally involved in, and then also talk about the GFSI scope J1 and J2, talk about hygienic design versus food manufacturing. I think from my experience, liaising with various stakeholders within the food industry, there seems to be some misconception or some misunderstanding in terms of how does this thing that we call hygienic design, how does it actually fit into into our normal manufacturing processes. And then I'll share with you briefly some detail around the hygienic design risk management and how that process actually flows. Right, just in terms of contact detail, if you can see on my screen, please, following my discussion today and our discussion, please reach out to either myself or Anne Wallace, our secretary for EH Regional Section South Africa. Right, so who is EH? EH is an organization that was founded in 1989 as a non-profit consortium, and you can see there was quite a number of stakeholders involved: equipment manufacturers, food producers, suppliers to the food industry, some research institutes and universities, and also public health authorities, all seeing an opportunity to collaborate around food safety, around hygienic design, and how, from a subject matter expert, how we can actually disseminate information across the industry, not just locally in Europe. That was where it started. In 2019, EH decided they would like a global footprint, and that's where we started the regional section in South Africa. So opportunity for everyone that has a stake within the food and beverage industry to contribute and to benefit from this. And my view is, at the end of the day, is that us as consumers are actually the beneficiaries at the end of the day. Just in terms of EH, it works on a membership basis. So you'll see our membership is there's 141 individuals, there's 67 institutes, and over 610 companies globally that is a member of the EH organization. And our geographical presence, you can see obviously Europe and how it's expanded into Asia, Africa, North and South America as well. So what do we provide? We provide training. This is just a summary of some of the trainings that happened up to 2023. We have authorized trainers. There was training across 600 plus hours and 335 plus trainees and attendees. And that relates to what we term the Advanced Hygienic Design course, and I will share with you some detail around that later. Another also on the EH product portfolio is the certification, testing and certification of specific equipment and items used in the production of food. There you can see sensors, pumps, valves, etc., where EH has a very specific certification program, an evaluation of cleanability, and then based on the outcome of that, EH will then endorse the piece of equipment as safe for use or ideal for use in food manufacturing. Just some of the product portfolio. Look at general principles of hygienic design, and we're going to touch briefly on those issues. Factory design, specific closed equipment for liquid foods, dry particulate matter, packaging, heat treatment, cleaning and validation, obviously very important. Test methods, training and certification, and then also continuous training, in other words, developing training material to the benefit of the industry. So it's mainly 10 focus areas. There's over 30 active working groups. So EH would write guidelines, these working groups that would comprise from people all throughout the industry, and subject matter experts providing input, and guidelines are written. It's all voluntary, and at this point in time, this is 55 plus, but we're already at 58 plus guidelines that's been issued by globally. Right, that's just as an introductory. The important part is that we need to talk about what is the practicality around hygienic design, how does it impact us as food producers, and what is expected from us. What do we need to look for? How do we approach it? And how do we mitigate risks that has been identified? So from design principles, there's basically 10 principles within the hygienic design risk management process. 5 of these are highlighted as critical, and I will share with you the detail around that. So principle 1, understanding your risk. We know all about risk. What is our risk? Is it physical? Is it chemical? What is it? Is it biological? Is my surface cleanable? There's a number of aspects that would render a surface properly cleanable. Are my materials suitable for use, for its intended use? Are my surface drainable? A big issue in a number of food plants I've been visited over my 38 plus years in industry. Drainability. Is my equipment accessible for cleaning? Very important. We have the saying, if you can't see it, you can't reach it, you can't clean it. Very simple saying, but obviously there's a lot that entailed around those issues. Are my materials correctly sealed? Are they properly welded? We talk a lot about crevices and dead legs. A lot of you are within the dairy industry, so a lot of CIP happens. So how effective is our CIP? Have we validated? Have we observed dead legs, etc.? Hollow bodies, obviously, that can harbor microorganisms in soil. Are cross-contamination vectors excluded? In other words, have we segregated properly? And then is my cleaning documented, inspected, and validated? So basically 10 principles. I'll briefly run through each one of these. So when we talk about our risk, defines machinery surfaces as either direct, which the product and material can come into contact directly with the material, or indirect. So you can see rather holistic. I just want to switch on my pointer. A rather holistic view on all aspects that could cause contamination of my product, and then also non-product contact surfaces, as much as direct and indirect surfaces are important, so are non-product contact surfaces, because obviously there's always a risk of cross-contamination from those surfaces. We need to understand our enemies. We're talking from a HACCP perspective. We talk about physical hazards, biological, chemical hazards, and what is the origin of those sort of problems? It could come from our raw materials, our processing machines and equipment. Obviously, that's where we place a lot of emphasis. Our environment, the personnel, and also maintenance. So again, a holistic view, understanding where these hazards are when we conduct our risk assessment. We need to take all of these aspects into consideration. The principle 2 is my surface cleanable? Now, we need to define between 2 different processes. We talk about open processes, typically sometimes a very complicated design, difficult to clean, takes a lot of time to ensure that we remove soiling, microorganisms, etc. So very complex. And then in terms of closed surfaces, we talk about milk, beverage, um, very lot more closed surfaces, transfer from tanks into different holding tanks, through pasteurizers or sterilizers to packaging, etc. So we need to understand that the risk is very different when we look at these two different processes. Are my materials suitable? Very important. Is the material that I use, is it compatible with my product that I'm manufacturing? Is it compatible with the environment, um, cleaning and disinfection chemicals, and also the methods of cleaning? So very important, that compatibility. When you look at our materials, where we have overlapping material or material that needs to be joined, is it done hygienically to prevent soil increase, or do we have crevices? And we'll talk a bit about those aspects as well later in the presentations. On the floors, yeah, our joints, are they rounded in one piece, not trapping soil and water, etc. And then our surfaces should be smooth. And we'll talk about surface roughness later in the presentation. Again, how critical is that? How often do we see crevices and cracks and damage to material like stainless steel? And what is the impact? What do we, from a hygienic design perspective, we wish to have the surfaces as smooth as possible so that we can get proper cleaning and disinfection on those surfaces. Yes, just as some examples of where construction failed us. You can see some corrosion on materials, typically where we use different types of material, causes obviously different types of corrosion, galvanic corrosion, pitting corrosion, etc. Also, in terms of this types of sealing, there we have crevices, gaps, and even conveyor belts, obviously loose items that can actually contaminate our food. So key is joints should be hygienically, and surfaces should be smooth. And again, we need to take cognizance of the fact that we need to use the correct materials when it comes to constructing equipment. EH talks about surface roughness of less or equal than 0.8 micrometers. Obviously, on the pharmaceutical side of things, it will be a lot more stringent, but based on work done and evaluations done, EH recommends 0.8 micrometer as surface roughness on stainless steel. There you can see from this picture, there's some wearing and machining. How often do we see that? I see a beverage plant recently where they couldn't remove swelling, where they take from a stainless steel surface, where they take angle grinders to remove the swell, obviously damaging the stainless steel surface and causing other problems within the process. Obviously, electropolishing is the ideal, but not always practical within the various items that we use during our production process. Drainability, as I said, is very important aspect that we need to consider. Here's just some examples of vessels where the outlet is positioned at such a point where you've got stagnant buildup and not properly drainable. Same with this vessel setup. And just through proper hygienic design, you can actually mitigate that risk and ensure that vessels, for example, are completely drainable. When you look at horizontal surfaces, again, residues and soiling building up. EH has some very specific guidelines in terms of fixtures like this. Is what should the gap be, and the purpose or the clearance. So obviously the purpose of that is so that you have access to clean, and then also the angle at which these cabinets, for example, would be designed is so that it doesn't accumulate soil and dirt. That's just an interesting picture within a filling machine. You can even see that the bottom section of the filler machine is actually sloped for that same reason to ensure that surfaces are completely drainable. Then the exterior and interior of all equipment must be self-draining, drainable. Again, we can look at a very complex design here. A lot of difficult areas to clean, a lot of areas for soil to accumulate, for microorganisms to grow and survive. And then perhaps a design like this, sloped, lid sloped away from the product, are things that we need to consider from an accessibility perspective. Yeah, is my equipment accessible? There's a piece of perspex joined to look like a stainless steel surface, and you can see the soil buildup within that area. Again, very difficult to clean. How often is that perspex removed and cleaned? And then obviously from a design perspective is what is the purpose of that piece of perspex? Can we design it differently? Same here, we've got some areas that will be difficult to clean. You've got corrosion. So obviously accessibility, inspection, and then maintenance becomes an integral part of the activities that we need to consider. Just some hygienic design criteria. When you look at closed equipment, we're talking, so what are the critical aspects there? Is the seals, the welds, the pipe connections, do we have any dead legs? Are our pumps installed correctly, for example, that it's fully drainable? Here's just an example of a section above a spray ball in a tank, and there you can see the gap that would be difficult to access and clean in this design. In open equipment, there we can see some damage to the stainless steel surface, causing crevices. There's a hole, what's they missing? Nut and bolt missing. Yeah, again, very difficult to ensure that we adequately clean that piece of equipment. Just some pictures of a conveyor belt. Again, the design, if you look on the side of this conveyor belt, there's metal to metal overlap, obviously creating areas where soil can build up. So better design obviously is to have a smooth one section. And then also around cleaning of conveyor belts, another design is, for example, the belt lifter lifting up so that we can ensure that you clean the belt and also the conveyor structure adequately. I've been in a conference in France, and where guys have designed some good CIP systems to clean underneath belts, easy to operate, to assemble, and so there's a lot of technology that we need to and can consider in relation to conveyor systems and conveyor belts. Here's just some more example of this electric box. Clearance here it's adequate for accessibility, but here you have a horizontal surface again. So do we have an issue with regard soil buildup, cleaning and disinfection in that area? Cabling, very interesting. This is a typical example of what we find in food plants. Perhaps a better option is to have all these cables in one sleeve, and then it allows you obviously to clean each one of these separately, which obviously will be a lot easier task than to try and clean each one of these separately. Here's just some more examples of how it fits. One of the big issues that happens is these cables would go into a sleeve, and then another piece of equipment might be installed at a later stage, and then what happens, the maintenance guys just just cable tie the other section to this, so again causing problems of soil buildup. So again, when we do this, we need to consider all aspects of future design in terms of how we're going to manage that. On principle 6 is, are my materials correctly sealed or properly welded? So yeah, you see different types of welding. Again, if the weld is not adequate, not correctly performed, as a lot of you would know, to weld stainless steel is quite an art. And again, do we pay enough attention? And I'll show you later on with enclosed systems what we find where pipes were welded to transport product through. So again, not very good welding. And we talk about surface geometry. So what would be a typical, if we have an overlap of material that we need to join? Obviously, if we join it in this manner, there will be soil buildup here. Our blue section is our product. You'll have buildup of soiling there. Perhaps a slightly better design is to curve that, but still you'll have soil buildup. And then ideally is to have it in that design with a continuous welding to ensure there's no crevices or any areas that might be a risk to our product. Here's just another example of a pipe that was welded. There's a step there. Just look on the inside of this, and 9 out of 10 times when you look at this pipe from the outside, it will actually show very good welding and good penetration. However, yeah, you can see when you actually go inside the pipe what the surface looks like. Shaft end couplings. Again, we don't want metal to metal contact, obviously, because that creates a crevice where soil can build up. And then domed nuts with some proper sealing, obviously the better option. So principle 7, are there no crevices or dead legs? So typically dead leg, we've got our CIP flow in this direction. Then we have our valve, and the rule is if that is longer than the pipe diameter, then you are creating a dead leg. So again, we need to, when we do our CIP validations, ensure that we identify those and that we correct them. It's Same thing applies here. This is just an example. So you've got your CIP fluid flowing from there into this direction, and then you can see here is hardly any mechanical action. So how would you clean that area if you don't have any mechanical action? Very, very difficult. So again, we refer to the different guidelines from EH to give us some guidance in terms of how to correct this. There's some welding requirements. It must be free from edges, mustn't be any cracks, and we need to, where necessary, obviously treat the metal surface post the welding. This is just an example of some misalignment. Within the EH guideline, we allow for some deviation, but it's all obviously the bigger the deviation, the bigger the risk of soil accumulation. Here you see an example of excessive penetration on the inside of the pipe, and there you can see there's no penetration, and we actually go through during our formal training. We actually go into welding in depth and looking at all aspects that may influence or may affect our product negatively. Are there hollow bodies? Obviously, we don't want hollow bodies because there's water, soil, microorganisms, all things that can actually accumulate when we've got hollow bodies, and it's not always easy to clean it. And even from a maintenance perspective, how often would we go and disassemble a section like this to see what is on the inside? So closed areas is preferably. There you can see an example. What did we say? If you can't see it, you can't reach it, you can't clean it. And this is now typical on the underneath a piece of equipment. You can see the soil that accumulated there. Principle 9, we talk about cross-contamination vectors, and this is really about segregation from high, medium, low risk areas. What is our product flow? What is our traffic and movement of people, of product, of packaging, all aspects that we need to consider to prevent cross-contamination. And obviously, doing a greenfield setup building, it's important to ensure that this is in the design phase before any work starts, just to ensure that your flow is correct. Principle 10 is my cleaning documented, inspected, and validated? Very important, and I'll share with you some practical examples of some work that we've conducted. Right, so why is it important? This thing called hygienic design. So if we take typical flow of milk tanker would arrive, you've got your soil load, you would transfer it into your milk receiving tanks, you'll do heat treatment. So what happens to your microorganism concentration? It would decrease. Obviously, that's why we're treating it. And then good hygienic design through our processes, storage, distribution. Obviously, there'll be some growth of microorganisms, increasing the concentration. That's with good hygienic design, and obviously it will be exponential and lots more where we've got contamination because of poor hygienic design, material and equipment. So just a graph to indicate that. When you talk about cleaning, there's a number of cleaning methodologies, but if we talk about open plant cleaning or foam cleaning, you've got low pressure, you've got medium pressure, and you've got high pressure. And obviously, we need to ensure that we operate at the correct pressure so as to prevent any contamination due to formation of aerosols and others, which I can show you. So if you can see typical high pressure, you can see the aerosols compared to this type of clothing. So very, very different outcome when it comes to selecting the correct equipment when it comes to cleaning. Some practical applications in South Africa. Yeah, you can see where we've used the different EH guidelines in an assessment at a plant. And here are just some pictures of where we've identified problems in relating to accessibility. How do you access it? How do you clean it? Dismountable joints. How hygienic is that? How often can you clean it? What's the condition of this, of the rubbers, etc. And also, yeah, you can see quite a difficult area to access for cleaning. Another practical application, when we do CRP process validations, these are the principle or the guidelines we would use when we do that assessment. Yeah, you can see, and these are pictures from the actual validation that was conducted. You can see some corrosion at the welding points. So what is it? What are the factors? You need to look at flow. What is the flow within your pipes, flow to your spray balls, the spray pressure of solution on the outside of your tanks, etc. So all aspects that we need to consider. Other factors is the swelling and swirl composition. Is what type of swirl are we wanting to remove, and what is its composition, and based on that, you can then get the correct chemistry to ensure that other than the hygienic design, the correct flow, etc. of the system, is that we are using the correct chemistry in terms of product that we use to remove soil from the surfaces. Microbiological fouling, I talk about detergent chemistry and the cleaning methodology, all factors that we need to consider. What is our risk? What is acceptable? And how do we mitigate those risks? Another example, as I say, it's a dairy focus. So when we talk about CRP efficacy and efficiency, in other words, how good can we clean it? How best can we clean it with the optimum quantity of chemicals? So this is just an example of work we've done where I'll just use the sterilizer one. This is the amount of caustic that is used. Month one, we've done the benchmarking, and we then would implement the various mitigating steps and factors to ensure that we optimize consumption. This is an example of caustic and acid. And again, factors that we consider is flow, hygienic design principles. We look at dead legs, the design. When we talk about valves, pumps, pipe couplings, what is it? So yeah, we're talking about efficacy and efficiency. We also do similar to when you have shelf life problems on the product, is we need to do a proper validation to establish possible causes. Another thing, when we talk about, we've obviously got different tools to support us in optimizing. And this is just a typical example of where we've got a pre-rinse. It's based on turbidity. Here we can see that we're wasting time here and water. So by the way, because that water normally goes to drain, the caustic, it's cleaning, there's time saving here, there's intermediate rinse, there's time saving, etc. So there are tools available, and EH has written a guideline specifically on CIP that is very helpful also to support you in managing efficiencies and risks and other aspects. Just another example of tools are the different spray balls, where we have a static spray ball, where we've got free rotating, we've got slow rotating, and we have orbital spray balls. Again, aspects that we need to consider in CIP. Chemical, time, and water, you can see that the saving goes more towards this type of spray balls, and mechanical action also improves at the same time. Some pipe connections, very important, and I think often neglected in our food plants, is what type of pipe connections do we use. There you can see connection like this. You have a crevice there where soil can accumulate, and in a pipe connection like this, there's no controlled pressure, and what can happen is this can actually protrude into the product. This is the product flow section. So again, all aspects that we need to consider during our validation processes. Here's just an example of a pipe connection that is where you have proper center sealing. You cannot overpressure it, over tighten it. So obviously an ideal situation when it comes to pipe couplings and mitigating any risk of soil and product buildup in those different areas. The other aspect that we need to consider on the elastomers is the type of elastomer. How often does it need to be replaced? Because what is the common thing happens is when we start seeing a leak, what do? Rather than replacing the elastomer, we start tightening the section, and obviously creating more problems for ourselves. Again, because you can't really see what's happening on the inside of those pipes unless you have an endoscope. So that validation that I showed you earlier is where we would go with an endoscope into the different sections and go and inspect and see exactly what the welding would look like, and what also connections like this, if there are any issues. Good. Just on the GFSI scope J1 and J2, which was issued in October 22. So EH had written a white paper on this aspect. J1 relates to the equipment manufacturers, and J2 relates to the equipment users, so the food manufacturers that what needs to be considered. This white paper, if you go to the eh.org website, this white paper is free and you can download it and have a read through it. It actually gives you very clear indication of areas that you need to consider as it relates to the GFSI. In addition to that, the FSSC Foundation has written a guidance document with regards equipment management, which they released in September of last year. And very importantly is that we now need to start managing the equipment that we procure in different phases. And I'll go through the phases later. It's not just piece of equipment looks good, therefore I would buy it, or it's cheap and I would buy it and use it. We need to go through a very specific process of risk identification and base our decision on those aspects. So the two critical areas that the FSSC has included now under section 2.515 on equipment management is there must be a documented purchase specification and an evidence that it has been met. There must be a risk-based change management process for equipment. That is for new equipment and existing equipment. So in other words, if there's an addition to a current piece of equipment, there needs to be a proper risk assessment conducted and manage accordingly. So that's also, and as I explained, that will start from the design process before actually it reaches the factory floor. So just to link the aspects of what we talk about hygienic design and the normal food safety HACCP type concept that we talk about relates to, on the HACCP GMP, it relates to the process, and you look at product quality. So the risk assessment is based on the product. When it comes to hygienic design, it's obviously the machinery and then the different phases that we need to consider, and it's about the equipment quality. How good is this equipment for its intended use so that it can comply with our different requirements to ensure that our products are not contaminated. So just a pictogram that explains that process. So EH has written a guideline 58, hygienic design risk management. And what's important is that one needs to consider the entity life cycle phases for each piece of equipment that you're going to procure. So you start with the construction at the supplier. Does he have your specifications? Have you communicated that? Has he agreed to that? The transport to the food manufacturing site needs to be considered. The manufacturing site itself. So we talk about installation qualification, and then we talk about process qualification. So in the operation, during the food processing, during cleaning and disinfection, have we identified the risks and have we mitigated or put in place steps to mitigate any of those risks? From the guideline is the process flow of doing a risk assessment, starting with the scope, identifying the hygiene risks assessment, and then how to reduce that risk. I just highlighted that section because what this depicts for us is that if we are proactive, in other words, our design communication to the manufacturer, equipment manufacturer, is good, and they understand our expectation, then we already mitigate the risk in these phases, which is a lot easier to try and, which you can do, but it's then a lot easier than to try through SOPs, works instructions, and other engineering controls to try and mitigate risk. So very important that the communication needs to happen there. The guideline can be used by food manufacturers as well as suppliers. So they can, there's a number of, you'll see all of these are checklists and guidelines in terms of that. Yeah, I've just highlighted some of the principles. Criteria is the materials. What type of materials is of concern to us? Have we identified them? Our ability to segregate and the impact of the different materials. Other criteria, ability to clean. Have we defined our cleaning agents? What lubrications are we going to use? Are there any allergens? All aspects that we need to consider during the risk assessment. Ability to access, as we said, should be readily accessible for cleaning, disinfection, and inspection. And these are the typical components that could be a risk in our process. And then drainability. What the guideline also tells you, so you've identified your risk, and then how do we manage that risk? Okay, here's an example of ingress of soil or ingress of microorganisms, and then how do we mitigate that? In this case, for example, a single or double mechanical seal on the shaft might be the solution to mitigate that risk. Right. Then just I've really tried to spend some time giving you a good overview of what this is. When we talk about hygienic design, we have a 3-day course, a formal course on hygienic design that we present. We're presenting next week one in Stellenbosch, where we cover all aspects. You can see the modules here, and you write an exam. Once you pass the exam, the University of Pretoria have endorsed this, and they would then issue you a certificate, and you also qualify for CPD points through SACNAFs and EXA, the engineering organization. Then just a list of EH certified equipment, just some links that you can follow. This is actually for free. The EH position paper on connections, pipe connections, and then also the white paper on GFSI hygienic design scopes, J1 and J2. You can follow us on our website, on our social media, newsletters, etc. Should you require any more detail. And as I said in the beginning, is should you wish to have any assistance, please don't hesitate to reach out to me. Thank you.
Thank you so much, Piet, for that very insightful presentation. I am sure of it that the people in the audience appreciate the importance of the aspect of design and equipment. And with that, now, audience, it is your turn to post any questions that you've got. Thank you, Carol. Thank you, Rafielwe. Yet it seems like the audience have enjoyed your presentation. So I hope that we will get some questions as well. And Piet, you and I can put our camera on so that we can talk to one another face to face, so that everybody can see. We are here. It's not a recording.
Good, good. Good.
Okay. Piet, I think the thing that comes up for me is that you are sitting in a scenario. Either you are in a plant that is an old plant, and you know that all these beautiful things about design and equipment and layout and processes weren't looked at in the beginning, and you now need to fix and try to uplift, because like you've said, people that's got FSSC certification now have got this full thing about the risk assessment of the equipment and all of that. What is your suggestion in terms of what is the best way to mitigate your current challenges that you've got in terms of your design?
Yeah, yeah, it's an interesting question, Adele, and as you know, I was referred to when we rewrote the SANS 10049 standard on GMPs, etc. Um, not much focus were actually given to the real hygienic design of equipment. Um,
Mm,
in other words, companies will find flaws within their current system, and for me, it's a case of uh, doing a risk matrix. Take your current setup, put together a risk matrix. I mean, we walk through the plants every day. Um, you've got maintenance looking at, and people see problems. So putting together a risk profile or matrix, and
yes,
then starting with your higher risk, and then try and based on the information that you've been given now and the guidelines that you have access to, is start rectifying that, because you can obviously think some of it might involve a lot of capex, capital expenditure, which obviously you can't do immediately, but that would go into a more medium term sort of plan. So
mm,
that is key one, how to address the current situation. And then with the knowledge you have now, is that where you do expansions or where you buy new equipment, is to apply these rules and ensure that what you do is correct.
yes, yeah.
That to me is the two parts to it.
Yeah, I think in terms of often people go to exhibitions and things like that, and they see a new piece of equipment and they immediately feel, well, I have to have that. It's going to, make my life so much easier in my process. But I think what you are saying is the question that the owner of a business should ask first is, okay, wait, before I buy this piece of equipment, speak to the QA, speak to the people on the floor, speak to maintenance to determine, is this piece of equipment that you're going to implement, is it really going to resolve or may it add, in terms of your risk assessment, in terms of challenges?
Yes,
And I
yes,
and I also think that, your principles that you spoke about, that if you look at a piece of equipment or any changes, the accessibility, the cleanability, the drainability, the material compatibility, the segregation, and the surface and the geometrics. I think those are also things that, you nearly have to have like a checklist for yourself
yes,
before you actually buy the new piece of equipment. Um,
absolutely.
you are speaking a lot about guidelines. How would the people get these guidelines, or where are the guidelines, especially the ones? How do people get the guidelines?
Okay, so on if they go to the website eh.org, www.eh.org, there are a number of these guidelines that are downloadable for
Mhm,
free,
mhm,
and then the others um, can be bought individually, or as I said, we work on a membership basis. So should your company become a member of EH, you will automatically have access to all 59, 60, 61, 62 guidelines. That's how the guidelines work.
Okay, wonderful. Another question that I would like to ask you is, what type of collaboration have you established with stakeholders in South Africa, recording in connection with hygiene design?
Yeah, again, a very good question is that we have now, you have a number of companies that are international companies that has outlets within South Africa. So
Mhm.
there's a number of them that is already a member of EH in Europe or whatever, and we collaborate very closely with all of them. So should you require assistance from what a hygienic drain should look like, to what type of mix-proof valve that we use in the dairy industry is ideal. So we have a whole host of of companies that we actually collaborate with. We run workshops from time to time where we invite retailers and suppliers to retailers to come and listen to this whole concept of hygienic design.
Okay, wonderful. Audience, the presentation as well as the recording is going to be on the Food Focus website as well as on the Dairy Standard Agency website. So you will be able to get all the information, all the links and everything that Piet has spoken about. You will be able to see that. It seems like, Piet, your presentation was so well that there's no questions from the audience. But I think but, but I think something that I would like to leave the audience with is that, in my days when I was still doing audits and things like that, if I think about any of the, factories, dairy, cheese factories and things that I visited, normally what the biggest challenges were in terms of equipment that is placed in very small areas, so it's not cleanable, it's not accessible. There's always condensation challenges. There's always water, the drainage, the floors that's not being sloped. And many a times, people would use epoxy floors, but they will not take into account in areas where they work with brine, you need a different type of epoxy because the brine will have an effect on the epoxy. So I really feel that, when it comes to design, yes, like I said, if it's an old premises, like Piet said, you need to do that walkthrough, that risk assessment, keeping your eyes open in terms of how's your flow, how's everything working. But I think I beg your pardon. I think it's so awesome if you're going to have a new premises, then you can take all these things in account. But I think with these tips that Piet has given you and taking into account that if you've identified a risk, there's ways and means of mitigating it. And, you need your team to ensure that you can do that. Piet, thank you very much for your time. I hope that you will have an awesome day. And thank you very much. And thank you very much for the training that you are doing. I'm sure that there's some of the attendees that will definitely like to attend those. Audience, like I've said, the presentation will be available on our website as well as on the DSA website. There's a short survey after the presentation ends. Please be so kind to fill it in because in that way we can determine what other information you are looking for. You will receive an attendee certificate. Please make sure that you save it because it's not possible to reissue it. If there's any questions, please be so kind to send me an email. Other than that, I would like to wish you all a great day. And the last webinar for the DSA for this year will be on the 20th of November. Please have a look out on social media and in our newsletter for the topic that it's going to be about. And I hope to see you then. Have a great day, everybody. Thank you so much. Thank you, Piet.
Thank you. Thank you. Bye-bye. Bye.